today we will be looking at dimension. What are the uses of dimension? 1. To verify the correctness of a given equation. To derive the relationship between quantities. And 3. To obtain derived units. Let's take an example. We want to derive the relationship between quantities. If V is velocity, is proportional to tension and mass per unit length. Mass per unit length in physics is given by m over L. Dimension simply means representing any physical quantities in terms of length, time, and mass. What is the formula for velocity? Velocity V is given by what? Displacement over what? Time. It means the dimension for velocity is Lt minus 1. What is the dimension for force? Because tension, T, is the same as what? Force. Force is defined mathematically as m times acceleration. So the dimension for force becomes mass is m, acceleration is Lt minus 2. So we bring it down to this place. We have velocity now, removing proportionality sign, it now equals to k, which is a constant. We now have t, mass per unit length. So we have v equals to what? K, t, n over what? L. Therefore, v now becomes what? K into what? Lt, mlt minus 2 multiplied by what? M over L. So that of V is Lt minus 1. So we substitute Lt minus 1 equals to K into M Lt minus 2. So take this up, we have ML minus 1. Now we assign variables. So we can assign variables this way. Let T take X and let mass per unit length take Y. So in that case, we now have Lt minus 1 equals to K into, for tension, X, L also X, T minus 2X. Then we have for mass per unit length, M take Y, L take minus Y. So we ignore the constant because constant is always dimensionless in physics. It doesn't have dimension. So if that is the case, we come down here, we have Lt minus 1 equals to 1. And taking note of by collecting like terms according to law of indices. So we have n x plus what? Plus y. Then we have n x minus what? Y. Then we have t minus 2x. So we collect like terms. Now we compare both sides. Remember, whatever you do to left hand side, you must also do to right hand side. So if that is the case, it means we have to introduce n here. And according to law of indices, anything raised by 0 is equals to 1. And 1 times Lt minus 1 will also give us Lt minus 1. So we have n raised by 0, Lt minus 1 equals to what? Nx plus y, n minus n raised by x minus y. T raised by minus 2x. So therefore, we compare both sides for m. So here, what the power, the integer for m here is 0. So I say 0 is equals to what? X plus y. That's equation 1. For n, the power of n here is 1. So we have L. 1 is equals to x minus y call that equation 2. So for t here, t is, the power is minus 1. So we have minus 1 is equals to minus 2x. And that's equation 3. So from equation 3, make x the subject of the formula. And that, if that is the case, you have minus 1 all over what? Minus 2 is equal to minus 2x over what? Minus 2. By dividing both sides by minus 2, you have this. So x equals to half. So substitute x equals to half into equation 1. So we have 0 is equals to what? X plus y. That gives us 0 equals to 1 over 2 plus y. So that y becomes 0 minus what? Half. And y is minus half. So back to where we started from, that v is equals to k t power x and mass per unit length power y. So now x is what? Half, so we substitute. So v is equals to k t power half, and nu, which is y here, is minus what? Power minus half. So our equation now is complete. We now have the relationship to be k is equals to, take away half, that gives us square root t over what? Nu. Our equation is now complete. Thank you, viewers, for deriving this relationship between these quantities with me. So it means the relationship states that velocity is equal to what? The square root of the tension divided by the mass per unit length. Thank you.